Yes, बेटा. तो आज का जो हमारा टॉपिक है that starts from atomic number and what is atomic number. So atomic number, the concept of atomic number, it is actually the number of atomic number is number of the unit positive charges present in the nucleus of an atom. That is called atomic number. It is denoted by Z. So actually atomic number is Z is number of protons see, and in a neutral atom number of protons is equal to number of electrons. That means atomic number must also be equal to number of electrons. So you can write that atomic number Z is equal to number of protons or equal to number of electrons in an atom, or we can say in a neutral atom. So obviously if atom is written, that means it is neutral. Okay, so or for specification you can write it as number of electrons only in neutral atoms. Okay, because if it is anion or cation, number of electrons are different from the number of protons. For example, in sodium number of electrons is equal to number of protons, and that is equal to 11. But if we write it as Na plus, what it means? Plus means protons are more than electrons. Electron can be added or removed, but protons remain same. So that means in this case number of protons equal to its atomic number, that is 11, but number of electrons is equal to 10, because one of the electron is removed from sodium. It can be written like this: sodium positive plus electron. Same if we have chlorine and Cl negative. If negative charge is there, that means electrons are in excess. So in chlorine, number of electrons and number of protons both are equal to 70. But in case of Cl negative, number of protons are same, but number of electrons now is 1 greater than. This is the case. So atomic number is not the same as the number of electrons in an ion. In case of ion, number of electrons are different. Okay. Yes, madam. Hello. So, sorry. Sorry. Atomic number. I have done all this. Number of unit of positive charge, that is number of protons, or it also equal to number of electrons in the neutral atom. Okay. And number of atomic number equal to number of protons or number of electrons in a neutral atom. But if it is an ion, then number of electrons are different from that of number of protons. In a cation, number of electrons are less than the number of protons, and in case of anion, in case of cation, number of electrons is less than number of protons, and in case of anion, number of electrons are greater than number of protons. Next is discovery of neutron. Discovery of neutron. Now, after the discovery of proton and electrons, two fundamental particles, electrons have negligible mass. So entire mass of the atom was regarded as mass of protons only. Because when electron and protons only discovered, at that time, number of electrons equal to number of protons, that is proved to maintain electrical neutrality in an atom. And mass of electron is negligible because it was 9.1 into 10 raised per minus 31 kg. But mass of protons, so entire mass of the atom is due to protons only, and mass of each proton is 1.67 into 10 raised per minus 27 kg. So, when mass of the atoms is calculated, then mass of the nucleus comes out to be greater than the mass of protons. Mass of atom, because electron mass is negligible, so whole mass is considered to be supposed to be due to protons only. But mass of atom, when it is calculated, it is very, very greater than, in some cases, except in hydrogen, that is greater than mass of protons. So it was seen at that time if there are some other nucleons, means other particles in the nucleus, which are neutral, has no charge but has mass as that of proton, very close to proton. So at that time, neutral particles was discovered by Who discovered neutrons? Yes, beta. Who discovered neutrons? Covered by James Chadwick in 1932. Okay, when he bombarded a thin foil of beryllium metal with fast-moving alpha particles. Beryllium metal, it is bombarded by alpha particles. Okay, to give 6C12 and 0 and 1, and this is called neutron. When beryllium foil, thin foil of beryllium, it, it is bombarded with the fast moving alpha particles, and each particle was found to carry a mass of 1.675 into 10 raised to power minus 27 kg. That is the mass of the neutron. It is nearly same as that of proton, but no charge. It is slightly greater than the proton. Okay. So now neutron may be defined as a fundamental particle present in an atom carries a mass of 1.675 into 10 raised to power minus 27 kg and no charge. This is the definition of neutron. Now next is mass number. So what is mass number? Okay, mass number. Yes, beta. What is mass number? Mass number is what is mass number? So mass number is actually the sum of atomic number. Sorry, sum of, we can say, number of protons plus number of neutrons, protons and neutrons. And you know that number of protons is equal to atomic number. So it is plus number of neutrons. In this way, number of neutrons is equal to A minus Z. Number of neutrons is equal to A minus Z. Okay, A minus Z, the number of neutrons. And you know, mass number of an element is nearly the same as its atomic mass. But what is the difference between mass number and atomic mass? Yes, beta, what is the difference? Mass number is nearly same. Mass number is same as that of atomic mass. What is the basic difference between two? Atomic mass, sorry. The mass number and atomic mass number and atomic mass. What is the basic difference between them? Sorry. What is the basic difference? It is mass number is always whole number. Mass number is always but atomic mass is atomic mass may or may not be atomic mass may or may not be whole number. So now let us compare a, the composition. So to describe the symbol, what is the symbol used? Or one more thing, protons and neutrons. Protons and neutrons, they are combinedly known as nucleons. They are known as nucleons. Okay. Protons and neutrons, they are combinedly known as nucleons. So what is the symbol used? General symbol of the elements. What is the general symbol used? ZXA, or in some books it is written as ZXA. ZXA, like that. So Z is atomic number, A is mass number. For example, helium 2He4, then carbon 6C12, nitrogen 7N14, oxygen 8O16, sodium 1123, magnesium 1224. Okay. Next, isotopes, isobars, and isotones. Isotopes, isobars, and isotones. So first is isotopes. What are isotopes? Isotopes are one atoms of the same element which have the same atomic number but different mass number. For example, hydrogen, isotopes of hydrogen, 1H1, 1H2, 1H3, or it is also known as deuterium, and it is known as tritium, and one is known as protium. Protium, barium, and tritium. Second is, or one more example like chlorine 35, and sometimes it is not, atomic number is not written, because everyone know if chlorine is there, its atomic number is, it will never change. It is always 17. So it is written as chlorine 35, as chlorine 35 and chlorine 37. Chlorine 35, 37, 17 is not written, but it is understood that atomic number of chlorine is better. Up in a, the YouTube live is also going on, or आपका mic is always on. Okay. Next is isobars. Isobars. Isobar means atoms of different elements. Atoms of different elements which have same mass number but different atomic number. Same mass number but different atomic numbers. For example, argon, potassium, calcium. Now in these cases its atomic number is 18, 19, 20. But if mass number of all of them is 40, that means they are isobars, because they have same mass number but different atomic number. Same mass number but different atomic number. And last one is isotones. So isotones means these are also atoms of different elements having same number of neutrons. They contain same number of neutrons. Okay. So in these cases, both atomic number and mass number are different, but A minus Z is same. In this case, both Z and A are different, but A minus Z is same, because A minus Z is number of neutrons. For example, 6C14 7 and not 14, 7 and 15, and 8 O 16. So they are isotones. That means isotopes have same atomic number, different mass number. Isobars have same mass number, different atomic number. Isotones have different atomic number as well as different mass number, but have same number of neutrons. That's it. So these are isotopes, isobars, isotones. So you can calculate atomic number. Sorry, if we have, let us say, 6C, tell me how are Cl negative and S negative, two negative ion related to each other. So in these two ions, in Cl negative, number of protons is 17 and number of electrons are 18. In S2 negative, in S2 negative, number of protons are 16, number of electrons 18. That means they have same number of electrons. Cl negative and S2 negative both have same number of electrons. Such ions are known as, they are called isoelectronic species. They are isoelectronic species because they have same number of electrons. So what are isoelectronic species? The atoms or ions having same number of electrons are called isoelectronic species. For example, if we have N3 negative, it has 8 electrons, 5 plus 3, O2 negative, 6 plus 2, F negative, 9 plus 7 plus 3, 10, 8 plus 2, 10, 9 plus 1, 10, neon, again 10, Na plus 11 minus 1, Mg2 plus 12 minus 2, Al3 plus. They are all isoelectronic. They are isoelectronic species. They are isoelectronic species. Next is wave nature of electromagnetic radiations. Yes, beta. Electromagnetic radiation. What it means? What are electromagnetic radiations? Okay. Once again, come again. Mm, okay, electromagnetic radiations are the radiations or radiant energy, the radiations, or we can say waves, which are associated with electric and magnetic field, which are perpendicular to each other, perpendicular to each other, as well as to the direction of propagation. For example, let us say this is the direction of propagation. That means the electric and magnetic components are perpendicular to each other. This is direction of propagation. So then one is electric field and other is magnetic field. Electric and magnetic field. If it is electric field, then this one is magnetic field. So what are the characteristics of such wave? The first characteristic of electromagnetic radiation is they emit continuously. In the form of radiations. Okay, in the form of radiations, or we can say waves. First characteristic is they emit continuously in the form of radiation or waves. Second, the radiations, as I said, that is also characteristics of this type of radiation, that the radiations are associated with so radiations are associated with radiations are associated with electric and magnetic field, which oscillate perpendicular to each other and also perpendicular to the direction of propagation, or we can say direction in which the radiation propagate. Then next is, this is very important, that all the EM radiations is electromagnetic waves, they travel with the velocity of light. That is 3 into 10 raised to power 8 meter per second. And one more thing, these radiations, or we can say these rays, do not require any medium. Do not require do not require any medium for propagation. So these are characteristics of electromagnetic radiation. Okay. Like sun rays, they reach us after passing through the space which has no material medium. These are electromagnetic radiation. There are different types of electromagnetic radiations: X-rays, gamma rays, IR, UV, radio waves, microwaves, that we will discuss. But before that, EM radiations, they are expressed in terms of certain characteristics like wavelength. Yes. What do you mean by wavelength? So wavelength, it is denoted by lambda. It is lambda. So lambda is what? Lambda is it is the distance between any two consecutive crusts or consecutive troughs. It is the distance between any two consecutive crusts or troughs. And it is expressed as like angstrom or picometer, nanometer, micrometer. 1 angstrom is 10 raised per minus 10 meter. Micrometer is, or we can say micron, 10 raised per minus 6 meter. Millimicron, 10 raised per minus 9 meter, or we can say it as nanometer. Or 1 picometer, 10 raised per minus 12 meter. So first is wavelength, second is amplitude. Yes, amplitude. Amplitude, it is denoted by A. And what is it? It is the height of the crust. It is the height of the crust or depth of the trough. Is height of the crust or depth of the trough, and is also expressed in units of, yes beta, आवाज आ रही है? एक मिनट, हाँ बेटा. तो now is it okay? And is also expressed in the unit of length. Next is frequency, denoted by nu. So it is the number of wavelengths passed through a point in 1 second. See, let us say this is the point. So in this point, how many wavelengths or how many waves? This is the complete wave, right? So how many waves are passing through this point in 1 second? That is called frequency. It is actually number of wavelengths which pass through a point in 1 second. Pass through given point in 1 second, and the unit of frequency they are cycles per second. Per second or hertz, after the name of Henrik Hertz. Okay, and what is 1 hertz? 1 hertz equal to 1 cycle per second. So what is cycle actually? One cycle means one crust and one trough. That is called one cycle. One cycle is one crust and one trough. Okay, that is called one cycle. So how many cycles are passing through a given point in 1 second? That is called frequency. And do you know EM, the electromagnetic waves, they differ in their frequency and wavelength. Next is velocity. What is velocity? Velocity, it is denoted by c. So it is linear distance. Velocity of a wave is linear distance traveled by the wave in 1 second, and it is measured in meter per second. It is measured in meter per second. It is a linear distance traveled by the wave in 1 second. That is called velocity. Then next is wave number. That is nu bar. So nu bar, that is wave number. It is defined as the number of wavelengths which can be accommodated in 1 centimeter length. Along the direction of propagation. Okay. And what is the SI unit? Wave number is per meter, but we can use per centimeter, is commonly used. Now, what is wave number actually? If you write it mathematically, so wave number nu bar equal to 1 upon wavelength. So wave number nu bar equal to 1 upon wavelength. So what is the relation between wavelength, frequency and wave number? Yes, beta. What is the relation? What is the relation? Relation between wavelength, wave number and frequency. So first is C equal to lambda into nu. C equal to lambda into nu, or you can write it as nu equal to C over lambda, or wave number is equal to 1 upon lambda. So frequency is equal to C into nu bar. These are the relation in wavelength, frequency and wave number. Wavelength, frequency, and wave number. The relation is C equal to lambda into nu, or nu bar is equal to 1 upon lambda. Okay, so keep in mind these relations because we use them in the next is with Planck's when we write this Planck's equation equal to h nu, and we use place of nu in we can use lambda, or in place of lambda we can use nu bar. This is by these relations. Okay, next is electromagnetic spectrum. Electromagnetic spectrum. Electromagnetic spectrum. What is electromagnetic spectrum? Electromagnetic spectrum is the arrangement of electromagnetic radiations in order of increasing wavelength or decreasing frequency. It is arrangement of electromagnetic radiations in order of increasing wavelength or decreasing frequency. Okay. For example, energy of cosmic rays is maximum and wavelength is minimum. Cosmic rays, then gamma rays, X rays, ultraviolet rays, visible rays, infrared, then microwaves, radio waves. These are electromagnetic radiations. And you know, visible rays is in the form of Vigueur. Okay, so that's all. In the next class, then we will have Planck's quantum theory and next part of that is black body radiation. Even we will explain this black body radiation by using Planck's quantum theory. Photoelectric effect, I think that is not in syllabus this year. Then atomic spectra, emission and absorption spectra. Then we will come to those model. Okay, so that's all for the day. Okay. Okay, so yes, beta. So we are discussing this class 11th chapter wise whole chapter concept as well as its exercise questions, in text questions, examples, NEET, KE questions of same chapter. Whole 11th and 12th I will cover, and class 11th we will have session from 8 to 9, and for 12th we have session from 6 to 7 almost every day, and definitely from Monday to Friday. Be with me, support my channel, share with your friends, and do like video and ask your friends to join so that we have a big group. I will to grow my channel with the help of you all. There should be a contribution from everyone. Thank you so much. As a subscriber, you have the responsibility to help me to grow my channel. Thank you so much. Support me and with me in my endeavor. Thank you.